I'm Kara Grieger. I'm an assistant professor in environmental health and risk assessment at NC State and a co-director of knowledge transfer for the STEP Center.
And I'm Ashton Murr. I'm a postdoctoral researcher. We're here to talk to you today about a new paper that was published in Society and Natural Resources titled Stakeholder Views of Science and Technologies for Phosphorus Sustainability, a comparative analysis of 3 case studies in phosphorus recovery in the U.S.
This was truly a convergent research project that brought together historians, sociologists, risk governance scholars, environmental engineers, and biochemists to tackle the challenges of technology adoption, which is a pretty important topic for a science and technology research center. In some cases, we noticed that scientists and engineers have developed a solution for a challenge associated with phosphorus management, but those solutions have not always been widely adopted by stakeholders, and so we really wanted to understand why. And before going further, we want to point out here that we recognize the term stakeholder can be considered an imperfect and even offensive term to many. However, the field of stakeholder engagement does not yet have another term that's a perfect replacement and is widely adopted at this time. We hope that this changes in the coming years with more research to find a more appropriate and inclusive term.
And so we did what any good qualitative researcher would do. We asked the stakeholders what they thought. But we didn't just ask any stakeholders about any technology. We started with 3 promising STEPS technologies that were focused on some aspect of phosphorus recovery: urine diversion, wastewater treatment, and stable isotope source tracking. We worked closely with the researchers who are experts on these technologies to find the right set of stakeholder participants, and we conducted semi-structured interviews with over 35 stakeholder participants. We asked our interviewees what they thought of these technologies, where they saw barriers to further progress, opportunities for improvement, and if they had any needs that had to be met before the technology could be considered viable. We then conducted qualitative analysis of the interviews to identify key themes and common trends. We used our findings to develop case studies of these STEPS technologies so that we could make comparisons and identify if there were any similarities that might affect all new technologies for phosphorus sustainability.
This process of engaging with stakeholders to understand their needs, perceptions, and concerns is critical to the success of our work in STEPS in the knowledge transfer team. So our research can help ensure that phosphorus sustainability technologies can overcome those barriers and we can better achieve the STEPS 25 and 25 vision.
Through our interviews, we were able to identify a set of common barriers and drivers that affected all 3 cases, as well as a shared set of needs articulated by stakeholder participants. Across all 3 cases, interviewees emphasized the importance of economic considerations when adopting a new technology.
This means if the product is too expensive to install or too costly to maintain, it's unlikely that a decision maker will decide to implement the technology. In particular, participants emphasized that the low price of phosphate rock meant that many phosphorus recovery technologies were not economically competitive.
We also found stakeholders emphasized how laws and regulations create barriers to adoption of new technologies. Our interviewees described how existing laws designed to encourage stringent environmental protection may actually be undermining the transition to more sustainable solutions.
Stakeholder participants also gave us some very helpful insights on their needs. In particular, participants across all cases asked for more data, more pilot projects or trials to showcase what the technology could do, and some attention to the needs of the current and future workforce that would be responsible for using and maintaining these technologies.
One of the most exciting aspects of this work is that the research teams we collaborated with are already using some of the insights we gained to inform the way they approach their future research. They've been following up with stakeholders we interviewed to continue building that relationship to co-create knowledge. But you may be wondering, this research sounds important for the STEPS Center, but does anyone else care about it?
Absolutely. Not only did the research design of this project involve convergence between multiple disciplines and perspectives, but the findings offer a valuable contribution to many different scholarly fields. Certainly, scholars working in the same area as the 3 case studies we explored in the paper will find our results useful. But we also hope that researchers who work on other or different phosphorus technologies may be able to use our findings as a starting point to further investigate what stakeholders might actually think about their innovations. And lastly, this work contributes to the social and scientific literature and adoption of innovation related to phosphorus technologies.
Our research shows that innovative solutions to improve phosphorus sustainability face similar barriers to adoption. Our findings suggest that scientists would do well to work together to address these larger barriers through advocacy and coordination with other disciplines, such as scholars in economics, public policy, and governance. Working together can bring us closer to solving these wicked problems.